Hello, welcome. Let's try to solve Leetcode problem 421, maximum XOR of two numbers in an array. Yeah, so normally for this problem, there's going to be a really good solution, which is a hash table, but it's really difficult to think about it. Just imagine in an interview, can you think about the hash table solution? Yeah, it's really difficult. So the straightforward idea is by using a 0-1 trie. Yeah, because it's for trie, it is a data structure. Although the data structure is hard, but if we already learned what is a 0-1 trie, it's gonna make the problem much easier than we expected. So this means we have to try our best to learn this 0-1 trie data structure before using it. Yeah, and for this problem, definitely it is a very basic pattern or template. Yeah. So the idea is that, for example, I have a number 3 and 5. I will not use other numbers maybe. Yeah, maybe just 3 and 5. So this is 3 and 5. So for the binary representation of 3s, we're going to use 4-bit 0, 0, 1, 1. And what about 5? 5 going to be 0, 1, 0, 1. Yeah. So now we're going to build a 0-1 trie from the beginning. So this is the root node. So this is the root. Yeah. Now from this root node, yeah. So let me make it. So this is a root node. So now from this root node, we're gonna start from the highest bit to the lowest bit. Why? Yeah, because for each number, we are not sure which one is the biggest. How long is for the binary numbers? We are not sure. But we need to make the alignment. So the alignment is gonna be from the highest bit to the lowest bit. Yeah. So although it is possible to make it from the lowest bit to the highest bit, but that is not so easy for coding. Just for the coding, we're gonna start from the highest bit to the lowest bit. Yeah. Now what are we gonna do? So from the root, we're gonna build a 0 and 1. So if this is a 0, now for our trie, we're going to have a node, it's going to be 0. Because for our trie, the trie node can only be 0 and 1. Yeah. Currently for this 3, we find a bit, it is 0. So yeah, we're going to find its children, it's going to be 0. And then we're going to move our pointer to this children. And for the next bit, it is a 0. So we're going to start with the 0 here. And then similarly, it's going to be 1. It's going to be 1, our current pointer, and it's going to be 1. Yeah. And then we're going to build this 5. Similarly, the first bit is a 0. It is okay. So we go from here. As you can see, it is basically like a binary search tree. We can directly solve it by using the binary search tree. Yeah. But we're going to call it a 0-1 trie because for each of the node, there are going to be only 2 children. So the children can only be 0 and 1. That is why we're going to call it 0-1 trie. The second bit is going to be 1. So for this is 0, because this is 0, this is not okay. We have to use a second bit. It's going to be 1. And continually, we're going to find a 0. Yeah, because for this bit 1, there's nothing. So we're going to create a new bit which is going to be 0. And for this 0, after that, it's going to be 1. We create a new bit which is going to be 1. Yeah. So this is how we build this 0-1 trie. And this is the first step. So the second step is that we're going to use a search. So the search idea is that we still have 3 and 5. What are we going to do? First, we're going to search this number 3. Yeah, because we only have 2 numbers. So for this 3, we find a 0. It is okay. And then we find a 0 because it is a 3. Currently, yeah, for the next bit, it is yeah, let me just try to iterate. So for the first bit, it is 0. It is okay. And then the next bit is going to be 0. Yeah, because for the first bit, basically, we want to find a 1. Yeah, because 0 XOR 1 going to be bigger, going to be 1. But it is not possible because it always be 0. So this means from the first bit, we have to choose a 0. We cannot find a 1. It is not possible. Now, we're going to jump to the second bit. Yeah, so the second bit is going to be 0. Yeah, so we find this second bit, we're going to jump to 0. Yeah, So while we are checking this number 3, we're going to jump to this 0, okay? But at the same time, we're going to check the other bit. If there is a 1, yes, it is. So this is 0, this is 1. This means we can use an XOR operation to make 0, 1 to be 1. So at this bit, it's going to be 1. Yeah. Now we're going to continue to check the next bit. This is 1. Can we find a bit? Next bit, we're going to check it is 1. So can we find a bit 0? Yes, we can, because in number 5 we can find this bit 0. Yeah, so we're going to continue to go through this bit 0 to check. Yeah, so for this number we just check each bit, but we will not update the pointer. So the pointer is updated according to which number is bigger. Currently it's going to be this number 5. So from the beginning the pointer is going to be 0, and then it goes to 1, and then it goes to 0. Why? Because our bit is 1. Definitely we want to find a 0. It is okay, so it goes to 0. So what about the if we go to 0, 0 XOR 1, it's going to be 1. And then we're going to go to the last bit. Yeah, so for the last bit is 1. Definitely we want to find a 0, but there's no 0. So we have to choose a 1, because we cannot choose a 0, because there's no 0 at the left side. So this means the final answer is going to be 0, 1, 1, 0. Yeah, so it's going to be 6. Yeah, this is like the XOR operation of the two numbers. It's going to be 0, 1, 1, 0. So this is exactly what we are doing. Yeah, because for the last bit we will not do anything. Yeah, so after that, if we don't do anything, after that the bit is going to be 0. Yeah. So this is the basic idea, and how we calculate it, and how we build a trie, and how we use a search to calculate all the possible results. Now let's start coding. Actually, I'm gonna code it like a template, and because if you are familiar with the 0, 1 trie, you can use your template as well. But if you didn't know about it, you can use my template. Yeah. So I'm gonna prepare a slot in Python, because I'm gonna prepare a variable children. Yeah. This is gonna speed up the algorithm a little bit, maybe 1 second. But in Python, 1 second I think is enough. It's really good. Yeah. So we're gonna prepare a slot. Now we're gonna init the trie node. As I said before, it's gonna be a self.children. We're gonna prepare a children like here, like this variable. We're gonna prepare a children. But this children, instead of a hash table, because we know it's gonna be a 0, 1 trie, we're gonna prepare an array, and inside we're gonna prepare a none. Yeah, it means there's no value taken. It's gonna be just a none. Now we're gonna define another variable, another class. It's gonna be trie. Yeah, although it's a little bit more coding than we expected, but it is just the very basic structure of trie. But for this problem, it's gonna be 0, 1 trie. Yeah, but it is okay. Yeah, but this kind of coding normally it should be easy. Although it is hard, but after practice a little bit about the problem, normally we can write it by ourselves. Yeah. So still we're gonna define the init. So this is the init. So init is gonna run while we initiate this class. So whether it is the trie node or the trie, we're gonna prepare the init. We're gonna run the init immediately in Python. Yeah, so in the trie, we're gonna prepare a root node. Yeah, because for each of the time, definitely we need this kind of root node, because from the root node we're gonna try to insert a binary number, or we're gonna try to search a binary number. Basically, we need this root node. So the self.root gonna equal to this trie node. And then we're gonna prepare two functions. So one is I'm gonna call it insert a value x. So here I'm gonna give a pause because it's gonna be a little bit more coding. I will write it later on. So here gonna be search. We're gonna search a value x. Because if we insert all the numbers, definitely we can search any number. After search, we can get the final result. We can find the maximum number. So here I'm gonna give a pass as well. Yeah. Now let's start the main part. So first of all, I'm gonna initiate the try, and then I'm gonna insert all the numbers. So I'm gonna use the try dot insert directly with this number. Yeah. So finally, I need to find the maximum result. So here I'm gonna use a max with this search. Yeah, because we just need to enumerate all the possible numbers. If we just enumerate 3, maybe 3 with some number is the maximum. Maybe it is not the maximum result. Maybe we need to enumerate 5. Maybe 5 and 25, XOR 25 is going to be the final result. So we need to enumerate all the numbers. So we're going to search all the numbers. Yeah, because for each of the search, definitely we're going to find this number combined with other numbers. Yeah, it's similar like a brute force, but we're going to use this search. This number and try dot search. So for the number inside all the nums. Yeah, as you can see, the main part inside of coding is going to be just like 4 lines. It can solve the problem. But actually we have to implement how to use the insert and how to use the search. Actually it is similar, but let's just try to finish the insert first. It is similar like any kind of a try data structure, but this is only 0, 1 try. The coding is going to be exactly the same. Yeah. So it's going to be current going to equal to self dot root. Here, as this number is going to be really big, it's going to be 10 to the power of 31 minus 1. So here for this number, for the maximum bit, I'm going to prepare a 30. So for I in range, yeah, as the maximum bit is 2 to the power of 31 minus 1. So actually it's going to be 2 to the power of 30. Yeah, as I'm going to use the bit shift operation, so for the maximum number, I'm going to prepare 30, the highest bit to the lowest bit. Yeah, and then I'm going to check the highest bit if it is a 0 or 1. Yeah, or you can just check the maximum number and then try to find the bit length and try to reduce this number. Maybe it is less than 30. Yeah, you can increase the time a little bit, but basically this 30 is okay. You can try to choose the maximum number. Maybe 30 is enough. Yeah, you don't need to try to choose the maximum number, but that is also okay. Here for simplicity, I don't need to pass more variables inside the insert function. I just want to use this 30 here. It means the maximum number of the bit, so I'm going to use the 30. Yeah, and then I want to check this bit if it is a 0 or 1. So I'm going to use right shift. So for this number, yeah, I'm going to find the highest bit and right shift to I and 1. I'm gonna check this this bit, the highest bit, if it is a 0 or 1. So let me just use an example. For example, this is 3, but here we only use 4 bit. Maybe they're going to be 30 bit. Yeah, so for this 3, I'm going to check the highest bit if it is a 0 or 1. Yeah, if it is a 0, I'm going to insert a node, it's going to be 0. If it is a 1, I'm going to insert a node, which is going to be 1. If there's a no node, I'm going to initiate the node. This is similar like the try problem. Yeah. So if x inside the current.children, let me think about it. Yeah, I'm gonna check if it is inside or not. Yeah, maybe I can write it like this: self.children with x, because this x basically it is an index like 0 or 1, and for our implementation it's gonna be an index. Yeah. So if there's no node for this value x, if not current.children x, whether this x can be 0 or 1. Definitely there's no node. There's no such node. What are we gonna do? Yeah, so we're gonna initiate the node. So self.children x. We're gonna prepare a trie node. We're gonna prepare a new node. Yeah, this is gonna be an empty trie node. Yeah, because there's no node, what are we gonna do? We're gonna initiate a new trie node first. After that, we're gonna insert it. Yeah. So current.children and current gonna equal to current.children with this x. Yeah, so this is the insertion part. First of all, we're gonna try to find the root node, and then we're gonna try to find this binary number. If it is a 0 or 1, maybe it is a 0 in this example. Yeah. But currently, inside the current.children, inside this root.children, there's nothing because it is always none. Yeah. For example, the current.children 0, it is a none. What are we gonna do? Yeah, we just need to prepare a new node. So self.current.children gonna equal to a trie node, and then we're gonna insert it. So current gonna equal to current.children x. Yeah, so we're gonna prepare this 0 as our value, and the current gonna be shifted to here. From the beginning it is at the root, now the current gonna be here at the 0, and then the current gonna be shifted and shifted until we insert all the binary numbers. Now let me just finish the search. Yeah, actually search is gonna be a little bit harder. Actually it's gonna be the main algorithm why we can use 0-1 trie to solve the XOR problem. Yeah. So similarly, we're gonna prepare a root node, and then we're gonna check all the binary bits, and this bit is gonna be the same. Yeah. I mean this x is gonna be the same. We're gonna check the highest bit. But here we need to check if not current.children. We need as all the node, I mean all the 0-1 node has already been inserted into the 0-1 trie. We just need to check if it is inside or not. Yeah, and currently for this value x, this is the highest bit. We just need to, for example, this bit is 0, we just need to try to find a 1. If this x is 1, we just need to try to find a 0. So this means we can use XOR 1. So for example, if this x is 1, now we need to try to find if there's a 0. Yeah. So here we do not need to use not. We just need to check if we can find if current.children x XOR 1. We're gonna do something. Yeah. Else, we're gonna do other things. Yeah. So basically, this is the basic pattern. Yeah, if it is okay, so the current.children x1, XOR 1, so the current is going to be shifted to here. If it is not okay, so the current is going to equal to current.children. Yeah, so this means from here, if this is a 0, definitely we want to try to find a 1. Yeah, so for example, if this is a 0 at here, this is a 0 here, definitely we want to if this is a 1, definitely we want to find a 0 here. We just want to try to find if we can find a 0. If this is a 1, definitely we want to find a 0 here, but there's no 0. Yeah. So this is the basic idea. Because only in this way, by using the XOR operation, it's going to be the maximum number. Yeah, but how can we record the maximum number? We're going to use a result. And here, if it is possible, we're going to use the XOR operation to record the highest bit. So the highest bit is going to be 1 on right shift with this I. We're going to just check this highest bit. If it is okay, we're going to record it. And finally, we're going to return the final result. Yeah, so this is the search part. While we are doing the search, actually, for example, we're going to use the 35, actually we can find it's going to be 25. So this is why we're going to use the 0, 1 trie to solve it. So the idea is going to be very straightforward. The coding is going to be a little bit hard if you are not familiar with 0, 1 trie, or you are not familiar with the trie. Yeah. Let me just run it to check if it works. So yeah, I did something wrong. Definitely it's going to equal. Current going to equal to current dot children with x XOR 1. It still didn't work. My answer is 0. Yeah, let me just try what is wrong with it. So I prepare a slot with children and set the children, and for the trie I prepare a root node, and for the insertion if it is not inside, I'm gonna create it. Yeah, I think the third is okay. The insert is okay. Yeah, but before the insert, let me just check a value maybe. Try dot children 0. I don't have the children because it is a trie. Trie dot maybe trie dot root. And then I'm gonna find the children. Yeah, currently it is a root node and it has a value with none. Yeah, let me just try to check what is wrong with it. I think the trie, and I'm gonna insert it and I'm gonna check the final answer. Maybe the search is not okay. Let me just check. So the current is gonna equal to sub.root, and then I'm gonna prepare the result. If current.children x XOR 1, I'm gonna update the result. Else current gonna equal to current.children x, and then finally I'm gonna return the result. Yeah, I think it is okay. I don't know. Let me just run it. Yeah, and every time it is a 0. I don't know. Let me just print out the result. Yeah, so all my result is 0. -1, -1. Oh, this is hard. Let me just run it. Yeah, this means I didn't go to that path. It is always like else part. Yeah. No, it is not okay. I have to insert it from here. Yeah, so my first number is 3. Let me try to find it is always 0. This means my insert is not okay. Yeah, I have a value 3 and I will insert it and this value add 1. So if this is 1, I'm gonna insert it. And then it's gonna be 10, but actually I didn't insert this value. Normally here gonna be 1 and 1, but I didn't put it there. It means something wrong with my insert. Yeah, this means here is wrong. Yeah, normally for this value x, I can find a value of 1, but I didn't. Yeah, let me check my binary calculation. Yeah, from somewhere definitely I can find 1, but I didn't. No. Yeah, definitely for the bit 0 and the bit 1, I need to find this value. It's gonna be 1, but it is not. It is always a 0. So this means there's something wrong with my calculation. Yeah, it is not x. Yeah, I did something wrong. I need to use another value n to represent a new value. Now let me check this value. Maybe it's gonna be okay. Yeah, because I gonna always use this value x to represent it. Actually, it's not okay. I think. Yeah, now let me check that. So I'm gonna use another variable n, and here I'm gonna use another variable. Yeah. Now let me just check if it is okay. I think I did something wrong. It's gonna be a very silly. Yeah, as you can see now it is okay. This is 1 1. It means it is for this 3. Yeah, I cannot assign the same value because if I insert this value and now all those values gonna equal to x, and then I'm gonna use this value to update a new value. Actually, this is not okay. I need to use the original value for calculation. So if I assign it to x, it's a very silly mistake. Yeah, so we have to avoid that. Actually, for each of the value, I have to use this x, so it means it can never be updated. But I updated. That is why it is wrong. Yeah. Now let me just fix this one. Let me change to another variable. Yeah, so sometimes I think we also make such kind of problems, and if we cannot debug it, definitely we can never solve it. Yeah, it's a silly problem, but actually we already made. Now I've fixed this issue, and let's just check if it works. Now let me just submit it. Yeah, now as you can see, it works. Although the time is really long, but it is okay. Basically, this is a try problem. Yeah, it's gonna take some time, and yeah, and the time complexity is 30 times n gonna be 2 times 10 to the power of 5. That is why it takes time. Yeah, even I try to submit it once again, it really takes time because yeah, for the try problem it really takes time. But for the time complexity it is okay. Yeah, as you can see, it really takes time, but it is still okay. It can pass for all testing cases. I think that's all about it. Thanks for watching. See you next time.